Hello guys and welcome back. In this example I wanted to show you how we can create a procedural portal effect using just stops in Houdini and points. But before I do that, I want to show and talk a bit more about the advantage of using this method. And this is the render that we did together. This is how it looks like. And we've had 300,000 points. And then what I've done is I went ahead and changed this resample node. Okay, and now I have 3.5 million points. And this is a very considerable number of points. We can create some serious effects, particle effects with that. And the change here took just a couple of seconds to compute, and that's because everything is done in SOPs. There is no sims or anything like that. So I've increased this 2 times now. We have 7 million points. You can see I have the points here and I can tumble around, and it's great. We didn't do any sims for this, so we can create all kinds of cool stuff with this method. And I've with the motion blur and everything, I did couple of renders, and this is how they look like. And let's kick off another one together. So let's pick this area, for example, and let's do one more thing. I want to change the colors. So let's dive inside that mix, which we did here. I'm gonna change them to have a blue tone. Give this blue tone like that. Cool. Let's hit render. You know what? I'm gonna do one more thing. No, we'll do it next week. So let's hit render, and it's going. So what I've done, I changed the point count, and this is the raw one that we did together. And then I increased that, and this is how it looks like. And then I zoomed in on one of the sections, and this is how it looks like from close-up. And then I moved the camera similar to what we have now, and this is how it looks like from inside the volume. And all this visual, when you look at it here, is just points, and it's hard to conceive what's going to happen, how the render is going to look like, accounting for all this motion blur. This is a huge factor when you create particle effects that is point based. Whether it's a particle sim or you do it in SOPs, it doesn't matter. At the end of the day, we're rendering points. And this is the frame that we did together with the points. Obviously the rendering, we're just starting, so we're going to talk about that in later weeks. And let's start this second example, which is very similar to this. So let's do a few things to restore the scene. I'm gonna change the background to light. I'm gonna show the grid, and I'm gonna create a geometry. Okay, I'm gonna create a circle. A lot of things starts with very basic shapes. Okay, I'm going to change it to polygon. I'm going to increase the count. And the radius is 1, so the distance between this and this is 1, or -1. The length of the difference, how far the point is from 0, it's 1. The magnitude of that vector is going to be always 1. So let's extrude this. Okay, so we have a surface to work with, and I'm going to increase the division. Let's also increase this guy. And what I want to do is I want to create, how much did we, let's say 0.5. Okay, I want to create a ramp that starts here and ends 1 here. And if we look at this image, actually let's sketch something. Again, I'm going to talk about a few things that are supposed to go into week 2, where we'll dive more into the math and remapping and fitting, all that stuff. But I want to show you these examples so you guys can get started and thinking about what we can do. So what is the point position? we have the 0, 0 here, and let's say we have a point, and it is far point. It is 2 units on the x, 3 on the y-axis, and 1 on the z-axis. This is its coordinate. What does this mean? It means there is a vector from here all the way here, and this vector is the position. It's called p. This is how much is needed to move the point from its origin. To move this guy to this point, we need a vector that is of this unit. Then we can compute the length of this guy. We can compute the magnitude of that, and it uses the two squares that basically find this arc length, or the rectangle, the last edge of the rectangle. So we can use Pythagore to compute that, but the length is function, that's what it does. So if we compute the length of these points here, let's go back. If we compute the length of P, we're gonna get 1. So let's do that. Let's create a point vault. Let's dive inside. And let's compute the length of P and plug it into color. I just want to see it, or you don't have to create a new attribute. We can look at it here. So let's take a look at the spreadsheet. See, they're all 1. So what is the length of the points that we extruded here? Well, it's going to be the length of this. So let's delete 1 point. Blast this, delete non-selected, and let's compute the length of that. Let's take a look. It's 1.5. Okay. Well, we know that the minimum is 1 and the maximum is 1.5. We can take those values and remap them to be equal to 0 and 1. When the remapping is very, very simple. Let's open the sketchpad again. So let's say you have your screen. So this is your screen. It is 1920 by 1080, for example. And then you have the mice and whatever you're controlling the screen. You move the cursor this much, you move the mouse this much from here to here. The cursor moves from here to here, and this is what a remapping is. It takes this distance that is between 0 and 0.1, for example, and remaps it to 0 to 5. So when you move your cursor in a small surface, you can remap it to match this. This is what a fit range or remapping does. And we can take this range that starts between 1 and 1.5, and instead of using that, we can tell it to go from 0 to 1. So that's what the remapping does. And with this, we can use any linear function to control the values further, because we know it starts at 0 and ends at 1. This works really well with any ramp tools in Houdini, like the float ramp and the color ramp that we're going to be using. But we're not going to do the color at this point. So I'm going to dive inside. We got the length. Let's confirm our theory. So we have 1.516, and the minimum is 1. So let's do this. Let's fit that, fit range. It's between 1 and 1.5, and the new range goes between 0 and 1. If we plug this in, we get this ramp. And this ramp, we can do this a similar trick to what we did previously to create the UV coordinate. So let's try first the noise. Let's add this noise here. Let's see the result. Okay, so right now it's a vector. So let's change it to a 3D noise, and let's plug this into the Z offset, or let's plug it into the offset as one value, same offset for all of them. And let's use an add node. I'm going to use an add constant, so we have the controller here, and if we play, you can see it's moving along this path, but it's not behaving as we would have hoped for. So let's find the correct one, and we need to create the point position using this in conjunction as the z-axis. So we have the let's say we have the z and x position. Well, we don't say that's the truth. These points, they have y set to 0. So we're going to use the y-axis to be this guy that we've created. Okay, so let's create a vector to float. We're going to leave the x and z, and we're going to float to a vector. We're going to leave these guys intact, and we're going to connect our new y position, and that's going to go into the noise. Let's disconnect this. Let's take a look at the result. And now if we move this, we should see it traveling outward. Nice. So let's reduce the noise. 0.2. And let's play with this guy. And you can see now the ramp is going outward. And this is very, very powerful because a lot of effects, they have a very primitive shape, and this technique we can create a lot of cool and interesting effects. Now let's increase the frequency along these axes, and I want to stretch it along this. Let's set it to 0.1, and let's go back up and add some more points. So to do that, we can continue working with this geometry. Right now it's a surface. Right now it's a surface, and we don't need that. We don't need to keep working with these points. Houdini has a great way of scattering points onto geometry, and to do that we're going to use a node called scatter, and this will take the any geometry and scatter points on it. So this is my input. We scatter some points on it. You can see them there. I'm going to increase the count to 10,000. I'm going to turn off the relaxation. What this does is it tries to place them neighbor aware so they don't overlap at all. I like this, but this is not the case where I would use it. I'm going to turn off relaxation, and I want the points to be random. So I'm going to increase this to 10,000. Let's do 100,000. And let's take a look at the result. And let's dive inside and play with this. So right now it's quite slow, so I'm gonna lower the points. So let's do this. Let's do an add node and expose this outside. And let's promote these guys so we can control them from the upper level without having to come here. So let's see. So this is the offset, and let's set this to $F. It's not working nicely. Yeah, it is working because this was low, that's why. So let's increase it to 10. Let's set these to 0.1 and 0.1, for example. And let's set this to $F divided by 20. So that's one effects, for example, that we could use. I'm going to leave it at that. I'm going to copy these two. And I'm going to I'm going to create a different version. Let's set this to 1, this to 2, 10, 10, and I want to stretch it. So the reason it's not moving is because there is no frequency on the y-axis. So that's why. Let's divide this by 20. Cool. So now we have a map moving along this axis, and can change the frequency along this axis, and that will make the pattern more repeatable. Set this to 2 and 2. And this is another layer that we could use as well. Very cool. It looks 3D, but it's not. Okay, and then we can combine these two together. And this is one of the very important concept in effects, layering things together to create complexity, and we're going to talk about this a lot. So right now I've added these two. One of them is moving in and one of them is moving out. Let's reduce it by 50 so it's not crazy. So you can see the underneath layer is moving in and the upper layer is moving out, and that creates a huge amount of visual complexity by just doing something like that. So let me copy this, and let's do one more version. Let's try 5 and 5. Cool. And the thing is, it's very hard to view. It's hard to understand how this pattern looks like, but when you see an overlap there, that means that will be a much more visible line when we render it, because these points will not be visible that much, and these guys will be additive on top of each other. So let's increase the point count here. Let me copy this guy. Let's increase the point count. Let me change it to pixel. It is pixel. So in the render, when we render this, we're going to get those patterns to be much more visible compared to these guys. And in later weeks, we're going to create pardon me. In later weeks, we're going to create something that can detect the density of these points, and we're going to use that as masks, so that we create a much sharper and more defined details. So let's do this. Let's give each one of these guys a different color. So let's say this pattern is going to be a dark purple, just using a color node. This guy is going to be bright blue, and this one is going to be a more saturated blue. Now the OpenGL is not as good as the render, obviously, when it comes to this. Let me change the viewport to black, and let's do a close-up and just do a quick preview of this. So something like that. And you see we have a pattern of the points moving outward. We have another one going in, and we have a different layer. See that layering? That's very, very, very important to create complexity. You can have two effects moving, two effects on top of each other. One is moving just a tiny bit faster than the other, and another one moving in the reverse direction. That creates a huge amount of complexity. Let's do a quick render on these. And right now, I'm gonna add a trail node because I want to compute the velocity. Let's change this to compute vel. And let's create a camera, or we have the camera. And let's hit render and see what we get. I honestly don't know how it's gonna look like. This is the first time doing it. So okay, the point size is quite big. So let's do this. Let's create a wrangle node and set this p scale. And again, you don't have to worry about this at this point. So I'm gonna set it to 1. And here I'm gonna copy this value, which is a multiplier for the scale. I'm gonna also turn on velocity motion blur, and trust me, all these things will be talked about in depth later. It's still very big. 10 times. I don't want you guys to do any rendering. I just want to show how this could look like when rendered, that's all. And let's move to a different frame. And I think it's too thin now. It's hard to see. And you can see the lines are much more visible now, and these guys are less visible. We get some layering there. Cool, so the base layer is very, very visible, and the other guys as well. We could increase the point count there, but I think you guys got the idea. So this is another thing that we could do as well. Maybe we should do this. Let's increase the point count here to 5 times more. This guy 4 times more. And let's do a couple of frames from 5 to 12. Could be very big, the point size. I mean, yeah, we'll leave it at that. Cool, so you can see the layering with no, we didn't do any sims, and you can see we're getting 3 different layers. And this concept is something that we're going to be talking about a lot throughout this course. I don't have a huge amount of examples that illustrates it, but it's very, very crucial to think of layering effects together. Think of creating simple particle sims, and then when you add them together, you can create something really, really complex. It doesn't have to be a very complex sim. You don't have to create complex sims to create complex visual. You can just layer simple things together, simple layers, like the circles and these things, for example, and that will create the illusion of complexity quickly. So let's see, we started at 13. So this is the Houdini mplay, which is the native viewer that ships with Houdini. You can render directly to it from Mantra, and right now it's rendering a sequence live. So yeah, that's how it looks like, and I hope you guys like this, and see you in the next video. Bye bye.